going to talk about
wireless
radio.
Yeah. Just let me just unlock my screen here. Hold on a second. Just put that down.
Cool screen.
Oh, thank you. This is actually done by a couple guys who were just HAL 9000 obsessives, and for the oh, how did that quit? That's unpleasant. Let's open wireless robots. I hope it got all my settings. Yeah. Okay. So, yeah, that was it. Okay, let's try it from there. Woohoo! Okay, so, hi, I'm Dillo. Some of you know me as Steve. Hello? Yeah, some of you know me as Steve, some of you know me as Dillo. This works too, this might be better. So I'm here to talk tonight about a collection of tools, techniques, and hacks for cutting the cord and getting your robot on the network. Disclaimer, this is a very broad overview. So first of all, how many hams do we have in here? How many people who actually could say that they are a real RF engineer and they don't play one on TV? Okay, so you are forgiven in advance for cringing and running out of the room if I say anything that offends your technical sensibilities, because I know I can get kind of the same way when people start saying things about software and IT and stuff in general. It's a very broad overview of mostly stuff in ISM band, using mass market, off-the-shelf gear, and some hacks. Along with things that I've found along the way. My background is as a, basically I call myself a hacker, systems technologist if you want to be professional about it. I do have a mixture of a background in IT and also programming, software development. So that's kind of where I'm coming from. Okay, so yeah, this is background. So how do I come by this? I'm just kind of a geek. I also, and part of the reason this talk has been delayed some, repeatedly, is I do a lot of volunteer teaching and training on wireless networking, mostly for students and engineers, CS and engineering students in developing countries, for a group of, for a bunch of different organizations. Worked on wireless voice over IP network in Laos in 2003. I've been teaching and helping these guys out for almost 10 years now. So this basically takes me to Italy once or twice a year. Papua New Guinea in 2009 for another, that was also kind of interesting. And the reason I was absent from the past couple meetings is that I was either in Italy or helping out these guys in Bangkok at the Asian Institute of Technology. So let me just back up here. So that's sort of like me. Why I think I can say I know something about wireless networking. People usually talk about a wireless connection, like I have a wireless connection on my robot, or I have a wireless, yes, my computer has a wireless connection, and usually what they mean is something in the industrial, scientific, and medical band. That wireless connection can actually mean a lot of things. Radio, just regular ham radio, ISM band, data networks, GSM, TNC packet radio, satellite, which is its whole nother realm, and so on. So, there's also some stuff other stuff I want to get on the way, which is annoying legal stuff. The FCC, which controls most aspects of radio communication here in the U.S. And has a lot of weight with other countries around the world. There are things like, they control things like what is licensed versus unlicensed. This big thing called Part 15, which a lot of consumer off-the-shelf devices work on. They do certification of equipment, and they control a thing called EIRP, which is basically has a lot to do with how much you can transmit and the frequency and range, things like that. Licensed spectrum is something that somebody is usually paid quite a lot of money for the exclusive right to use it. So like a radio station or a TV station or something like that. They get to have a 50,000 watt transmitter and you don't, because they paid for the airwaves. And because they paid for them, they have, they basically get exclusive rights to use it. And if you just set up your TV station next to theirs, they get out their lawyers, something called the FCC, their friends in the FCC, and the FCC will get out the cat detector vans, and they'll go around and all sorts of nastiness ensues. Unlicensed is pretty much the opposite. You share the spectrum with anybody else who wants to use it, for just about any reason. So if they want to set up a transmitter next to yours that is impeding your signal, it's like right in your beam path, or is next to you but transmitting n times, talking n times more loudly and drowns you out, you and they have to work that out. That's kind of, it really is a commons. Certification, FCC certification, when something has been certified, so it's been certified under Part 15 by the FCC, or it's been certified under this other part of the radio code by the FCC, and what they mean is it has been tested in usually a very expensive lab under very specific conditions to do that it meets these certain tests. It doesn't leak all over the place. It transmits in the band that it says that it does. If it's using a particular frequency hopping, it hops specifically within those frequencies and nowhere else. It's basically that it does what it says it's supposed to do. And the thing about the reason this is important for us is because the modification of the equipment is certified in these specific conditions that it was that the SEC tested it under. And if you modify it anyway, that breaks the certification. It's no longer certified. And that means things like if you decide you're going to put a bigger, more powerful antenna on your Linksys, or if you were going to put a bigger radio card, if you bought like a Metrics or some other sort of do-it-yourself Wi-Fi kit, and you decide you're going to take out the 100 milliwatt radio, the 20 milliwatt radio, and put 400 in there, that also breaks the certification. So companies like Cisco will do things like put really weird antenna connectors on their access points so that you have to buy their antennas. You can only use their antennas. And the whole reason for that is because it's very easy to tell when you've attached another antenna to it, or they make it very hard to do so because that would break the certification. So this is all things that you'll run into as you go out and you try to build wireless systems yourself onto your robot. This is why you can sometimes never find that, it's like, wow, everybody would want to transmit farther. Everybody would want to have a bigger, Wi-Fi range for their robot. Why can't I get a bigger card? Why can't I get a different antenna? Why can't I get a dish antenna instead of a little Omni? Well, this is why. EIRP is something that's also important to know about if you're going to be doing your own antennas. It's the amount of power that an antenna system would theoretically emit to produce peak power density observed in the direction of maximum antenna gain. It's the actual definition. So it's important when you're designing your own antenna for a system to say that a robot needs to maintain a long-distance wireless link over. Like something that was going to go out and explore a volcano. Once you went in a volcano, it's going to erupt, and so you have a teleoperated robot that goes out and it skirts around the rim of the crater, and it's transmitting over a long-distance wireless link that maybe you're 20 or 50 miles away back in the research center, so you want to know. So there is again regulation about how you can do this. What kind of transmitter, radio strength, things like that you can put on the robot, and it's basically calculated as transmit power of the radio minus cable loss plus the antenna gain. And it's restricted in the US and North America to 36 dBm. And the EU, I think it's 20 or 25.
For what? For Wi-Fi? That's what you're saying?
No, period. So now you can get, that's within the beam path. So if you're using
you
it,
say your 36 dBm EIRP applies to some particular service, radio service here. You're saying
this is for ISM. This is for open unlicensed spectrum.
Well,
Just in general, it doesn't matter the frequency. It's just in general.
What you're talking ISM band radios.
Yeah. So and what that means is that it can you notice I see an antenna system here. I'm gonna try and get through this really quick, so I have a bunch of other cool stuff I want to talk about. But the thing here is this can be anything. You can have like it can't be more than that formula can't come out to be equal more than 36 at the other end, and that can be like a low power radio with a really cool, efficient antenna, a really, really powerful antenna that really ups the gain, or a really powerful radio with an average antenna. So some combination of the two. And that's within the beam path. So you can have, like, for some of the trips, some of the work that I've done overseas, we've had like, 400, 650 milliwatt radio cards for a directional link that is going 130 kilometers and has like a 4-degree beam width. So it's very, very narrow, taking up hardly any space, and it still complies because doing a very, very tight beam path.
I have a quick comment here.
Yeah.
I think this is valid for the 2.4 gigahertz ISM band. Apparently there are, if my memory serves me right, apparently there are no EIRP restrictions on the 5.8 gigahertz. You can have your antenna with as much gain as you want, and you don't need to reduce the EIRP power. I could be wrong.
That may very well be true. That may very well be true.
So if you want to do long distance communication, 5.8.
So unlicensed spectrum, this is the last one of these, I think. Unlicensed spectrum is not just 2.4 and 5.8, but there's actually quite a few of them. There's 6 megahertz, 13, 26, 40, 433, 902. I think there's also like 838 or 863. Not many of these are used commercially, but these are the bands that the ITU, which is basically everybody's FCC, different countries, their equivalent of the FCC and our FCC agreeing that yes, this will be unlicensed. But the most important to us is 2.4 gigahertz and the 5 to 5.8 gigahertz because that's where 802.11, 802.15.4, which is Zigbee and RIME and a bunch of other things, and Bluetooth all live. We talked about this a little bit earlier. Just the number of things that out there is really huge and incredibly crowded out there, particularly in 2.4. A lot of companies are actually starting to make equipment in 5.8 because it's just getting too hard to do anything to come out with a device that actually really uses 2.4 and delivers the kind of sort of customer experience that they're looking for because everybody is using 2.4. For Wi-Fi, there's a bunch of different sections in IEEE spec for 802.11. We're mostly concerned about ABGNN, which talk about transmission and network topology, things like that. IEQX all refer to security or quality of service or some other mechanism that really doesn't have to do with, that's either like more software related, like security, authentication, authorization, things like that, quality of service, controlling bandwidth. I mean, that's kind of important. But for the most part, we want to pay attention to the topology ones, the topology sections of the IEEE spec, which are the ABGNN sections. So, to the point of the talk. Why ditching the links that you have put into your robot might be a good idea. From my experience for robots, Wi-Fi is mostly a waste of battery power, unless you have very heavy data apps, unless your application for your robot is making pumping out a lot of data. So if you have like a Connect hooked up to it, and you really do need to get the real-time 3D voxel streaming of the Connect data, and you need to be able to visualize that, perfect application for 802.11n. You really will need that 108 megabits. If you're just sending over sensor data, like you have your analog sensors, for ranging, like ultrasonics or IR or something like that, it's just like, text data, maybe usually like 3 or 4 digits, and you're going to have, times the n number of sensors that you have. So really just a few K. And so that's your, taking this power brick that goes on the off-the-shelf router, and you're plugging it into some sort of, strip or something that's hooked up to your battery. So you're powering the transformer, which then steps, which sucks up a lot of power, steps it down, puts it into the, puts it into the Wi-Fi router, which has maybe a 2 to 5 dB antenna on it. So where's all that battery going? Where's all that battery power going to? It's going to send a few K of data. It's just like riding a scooter, down a 24-lane highway. The other thing is it's not really designed for distance. In particular for mobile robots, it's not designed for mobility and roaming in the 802.11 spec. And in the chipsets that are manufactured, there is really no provision for roaming, for handoff. Like when you go outside of the range of the router, and you come upon the next one, how do you maintain your link back to the system that you're trying to connect to, or to the internet, or to wherever? How does the other system that you just came in range of know that you had a connection to all these services? These are things that are taken real care of really, really well by technologies like GSM. I work for Cisco. We also provide some really, really neat solutions for doing handoff on Wi-Fi systems around buildings. They also happen to be really, really expensive and proprietary. And they kind of layer over top of the radio layer, on top of the physical and the network layer. And they do kind of a lot of proprietary fiddling in the middle. So the stuff that you're probably going to get off the shelf, and it's probably going to be affordable, it's just not really designed for this kind of stuff. And also it responds poorly to interfering or competing users that are in the same band. One really good example of this is Bluetooth. Bluetooth hops around in the same, is a spread spectrum, so it hops around in the same frequency band that Wi-Fi does. There is the protection mode in Wi-Fi, there's the protection mode that allows 802.11b and G to coexist. So if an access point were to detect somebody was transmitting at a lower data rate, and it does this by looking at the frequency, it does this by looking at the basically the data rate that's the signal that's coming into the radio itself. So there's no actually like protocol header or anything that says, oh hi, I'm 802.11b. It's actually this is looking at it very much at the physical layer, at the radio layer. And so what it'll do is it'll step itself down. So what happens is Bluetooth hops into the middle of like channel 6, and the Wi-Fi router will go, oh, shoot, there's somebody here, and he's transmitting much lower. Step down, interference, slow down, and everybody's connection drops. And then the Bluetooth hops out. Oh, interference is clear, raise it back up. And the Bluetooth hops back in. And so what you have, the Bluetooth radio doesn't know anything about the Wi-Fi. It's not sensitive to any of this. And so it's just hopping merrily through your, through your coverage area. And meanwhile, your throughput rate is going like this, on the Wi-Fi is going like this. So you have no protection against that. So this is just a few reasons why you might want to look at, maybe not just completely get out of Wi-Fi, but why you might want to look at something other than just some the low-end, getting away from some low-end consumer off-the-shelf type of stuff. Of course, you can make counters to this because things like the WRT54G, some of the metric stuff, some of the Ubiquiti gear, all very hackable. And as I said earlier when talking about Cisco gear, there's ways to layer on top of this. So you can make kind of arguments either way. Personally, I think unless, like I said, unless you have like a really high data rate application, like you're doing like a Grand Challenge, a DARPA Grand Challenge, or you're doing like the Willow or something, where you're driving down the streets, you just really, really need to have that data flowing back to you, large volumes, and you need it all to be accurate and not drop packets or anything like that. That's great. So what should you be using? Here's a comparison of some different wireless technologies. These are all on Western Spectrum, and kind of what they're good at and what they're not so good at, and kind of some of their features. Wi-Fi we've talked about. Bluetooth is actually getting, as Bluetooth releases, as the Bluetooth Alliance releases new versions of the spec, which allow new versions of firmware to be generated. It's actually getting pretty fast. It's up above like 1.2 megabits now, which is certainly fast enough to do like stereo. Let me just reach under here. Not kill myself. This is a Bluetooth 2.0 stereo headset. There's not just a little crackly thing that crackles in your ear and sounds like you're talking through a tin can, so you know it's a phone call. These are stereo, and so I use them with both my laptop and with my phone, and they're really nice. And the DSP in them is big enough to actually do real stereo processing. Zigbee, which is a newer technology, is designed for pretty much an entirely different kind of thing than Bluetooth or Wi-Fi. Bluetooth and Wi-Fi are designed for streams of data to be coming through, either like a phone call or data from a keyboard going to a computer. There's going to be data constantly going through there, so they're always going to be on. Zigbee is designed for a wireless sensor that you like maybe bury out in a field somewhere, and then wake up a couple times a day, squirt some data back. Like you have like a soil moisture sensor or something like that. It wakes up a couple times a day, squirts some data back at a controlling node, and then goes back to sleep. The useful thing about Zigbee is that it's variable power. When it's idle, the power usage is in microamps. Like 5 microamps for the XP Pro chips to just kind of sit there, not really doing anything. This is without putting it to sleep. This is where it just sort of sits there. And they're very long range. The Orb Swarm project that I participated in, I don't know if you've seen this at Maker Faire and maybe at Burning Man, big rolling orb-shaped robots. There's 6 of them, and they all communicate over a mesh network. Using Zigbee. And we've had them out on the playa and had them spread out by several hundred meters to where the distance between the farthest ones has been kilometers. And they've still kept the network up and still kept in touch with each other, and they've still been able to position themselves with relation to each other and synchronize their lights and their sound. So Zigbee, if you don't need to shove a whole lot of data through, and all we're sending over that connection is each orb is sending its ID, its GPS position, the mode that it's in, and I think like the LED color, and the file name or the file index for the MP3 file that it's playing. So enough data to control them, and enough data to do like path planning and figure out where they all are. But in terms of like, what are you actually seeing on the screen if you have like a TTY hook, like Z-term or something like that hooked up to it, or Minicom or something, you're just seeing like a stream of about maybe 4 columns of data. So it's not really all that much. And then finally, cellular can actually be useful for some things. It has, because of what it is, it was designed to roam. It's designed to be mobile. Medium bandwidth, moderate latency, medium range. And when I say medium, I mean like tens of kilometers. This is just a slightly different way of looking at things. So the wireless here, where it says up to 300 kilometers, that's doing some really fancy research stuff. I know from the work that I've done in Italy, I know the guy who, Ermanno Pietroselli, who holds the world record for longest stable Wi-Fi link, which is 382 kilometers. And from pretty much one end of Venezuela to the other. And GSM, yeah, I'd say has a range of about 40 kilometers because there's a lot of use of GSM, a huge use of GSM in Africa. So places like Kenya and Uganda, Tanzania, Malawi, places like that, where sometimes you'll just have huge flat plains and there'll be like a cell tower kind of out in the middle of nowhere, or a cell tower on a mountaintop, and it just kind of casts out. And that's the only thing around for maybe 50 or so kilometers till you get to the next cell. So you can go pretty far with it, and it also, again, effective distance depends on kind of like the amount of data that you're pumping through. Go to powering here. There are 2 basic ways to power these things, particularly of Wi-Fi. Things like Zigbee and Bluetooth, they usually use like 3.3 volts or 5 volts for operational mode. Zigbee can go down to like 1.2 volts. It has a sleep mode where if you want to switch the power on it, you can. Like if you want to switch over to a small battery or something like that from mains, if you have like your regular LiPo battery and you just want to switch it over to like some sort of little sustainer battery. Things like Zigbee will take like 1.2 volts. I've got wireless sensor modes here. These are from a company called Zelurcia in Spain. It operationally uses 2 AA batteries. So its nominal power is 3.3 volts, and it will step down to 1.2 for some things. Just go ahead and pass it around. So powering IC is basically there's 2 options. You use battery, to a brick, or you can use something called power over Ethernet, and that's actually the more interesting thing. So I'll talk about that now. PoE is actually really, really popular in the long distance and experimenter, community wireless networks, long distance wireless communities, because it lets you basically attach an Ethernet cable to something and string the cable down a pole. So you mount your access point up on a pole, and you just have one single Ethernet cable, weatherproof, that goes down inside, and that's it. Yes?
Are there issues with lightning in that case?
Yes. You do want, we'll get to lightning arresters are a consideration, but the lightning arrestor is usually attached to the antenna. Because the antenna is going to be, when it's operational, the antenna is going to be energized, and it's going to be presenting a much higher EM profile to the lightning. So the lightning is much more likely to hit the antenna, go through that into the equipment, than to actually hit the Ethernet cable. So basically the idea here is that you have RJ45 is 4 pairs, And classically, only the 2 outside pairs were used, which leaves me 1 in the middle. So some years ago, some clever guy figured out, oh, hey, you know what? This pair is not being used, never has been, never will be. We could put power over that. And this is how you do it. You have this thing called an injector, PoE injector, which I have attached to my robot there. You have power going right in. You have power going right in here. One of these is for data, pure data, just regular RJ45, and one of these is PoE. And you kind of mux them together. They get twisted together inside this block, and then you plug it in the back. And it just so happens that it's like this. This is so there's like that. So this is an access point made by a company called Ubiquity, which is based out of Latvia. They manufacture these things. Let me see if I can just unhook this here. This is called Ubiquity Bullet. So you have PoE on one end, and then you have an end connector on the other. So you can put pretty much any antenna on there that you want. You're not just going to put little rubber. You can't not just a little rubber duck. If you want to put a dish or some other directional or a grid antenna or something, anything that has an end connector on it, you can put it on there. Pass that around. And then I'll give a demo of that with the robot. Because the cool thing here is that because this can be 12 volts, and it can go right into the device, you don't have to send it through a brick first. So the thing only needs like 230 milliamps or something like that at 12 volts, and that's all that you draw off your battery. So I've had this running around when it actually had some code on there that had running around. I've actually had it running around as an access point for pretty much a whole day. The only thing that you have to worry about with PoE is you have to plug it in right. That actually is a cable from somebody, one of the students at ICTP in Italy, who plugged RJ45 into the PoE slot with predictable results. So this is how it looks on a real robot. You have 12 volts. You have this going into, you have 12 volts here. That is the PoE, which has data and power going into the access point. And then you have this one right here is data coming in from like from a microcontroller of some sort, like a Beagle board or some single board PC or even a laptop or a netbook or something like that. And it looks like that. So, if you're going to use an access point, what mode to use when? Well, there's a very simple mode, which is just as an access point where you have a star topology network. So the access point acts as a repeater station, and everybody that wants to talk to everybody else has to go through it. In this case, the AP is usually handing out IP addresses through DHCP, or you get everything statically assigned. So if you just needed to talk to your robot by itself, and you didn't want to have to worry about getting somebody's password or getting on the net or something like that, and you just want to get like debug data off of it or video data back from it or something like that, and it doesn't have to talk to anything else, this is a good mode to use. It's really, really simple. It's like sort of the default mode on most APs. There's bridge mode, where you have like again, a single board PC or something like that needs to access a local LAN. So you would set it up in bridge mode, in which it just sort of transparently forwards whatever IP packets the host sends through it. So in this particular mode, you wouldn't get your address from the controller. You would get it from outside, from like whatever building, from like the access point you're trying to talk to, or from the building, or whatever. So the bridge just kind of forwards it blindly. There's a mesh, so if you have, like in the case of the org storm that I was talking about, If you need multiple robots to talk to each other, and then maybe eventually out to another network, you would use mesh mode. Not every access point supports mesh. Some of them that have come out over the past couple years support something called WDS, which is stands for Wireless Distribution System. This is a very simple mesh in which you kind of predefine individual nodes that are going to, basically to extend a network. I use this at home in my apartment. We have an Apple Airport Extreme. I live in an apartment in San Francisco, old style apartment that has plenty of sculpted plaster around the walls and the ceiling. And behind all of that, in case you didn't know, is chicken wire. So pretty much, unless you're living in a more modern, building construction in San Francisco, if you're living like in a classic Victorian or something like that, chances are pretty much every room is a perfect Faraday cage. And you're lucky if you can put one access point against this side of the wall and the other one at this side of the wall, they'll be able to hear each other. So WDS is really good for that. But it's kind of static, and it doesn't, you have to set things up beforehand. It's definitely meant to be something that's sort of put in place and kind of left there. This kind of mesh that we're talking about is actually much more appropriate to roaming robots, and it's something I would recommend for a situation where you have like a bunch of robots with sensors trying to communicate data to each other. If they're trying to send their sensor data back to a controller node, or they're just trying to talk and communicate with each other because they're self-discovering, dynamically routing, they figure out, they know when they come up on the network, they send out broadcast packets and to figure out who's out there. And as they come up on the network, they each advertise who they know, and from that you can figure out who has access to certain nodes and who has access to an external network connection, if there's like a default route or something like that. The downside to this, because there's all of this forwarding and reporting going on, is that as you get sort of deeper into the mesh, or you get kind of further out, sort of into the hinterlands of the mesh of the network, you start losing bandwidth because of this overhead. And it works out to be half bandwidth per hop in the mesh. It works out to something like that. So if you have like 100 megabits coming out of the wall, and like on a megabit access point, 5.5, I think I have calculations for this right, 2.2, and this guy over here is stuck at like barely a megabit, and one after him is going to be talking like, so you can get down to, you can go from like 54 megabits down to DSL speeds really quickly if you don't plan out your mesh. If you let it get too deep, because in order for this to work, in order for like one robot, if its battery runs down, and so it drops off the network and has the route, like this guy drops off the network, and his battery runs down. Okay, so great. How is he going to get back out to the network? Because suddenly one of his paths is, how is he going to get out to the network? Suddenly one of his paths has disappeared. So he has to go around and figure out, they have to basically sort of recalculate the topology of the network and recommunicate to each other who can now see what, and also let them know, hey, if you're trying to get to this guy, he's not here anymore. So just kind of stop trying. So there can be quite a bit of overhead for mesh, but sometimes it's really the only solution.
So,
yes.
Mesh, is there a, do you know if there's a package that's a part of the Linux Wi-Fi stack that will implement any of those meshing protocols?
Yeah, there's a bunch of them.
Okay.
I'll write it up here afterwards. But there is like I can think of it, there's at least like 4 or 5 well-developed, active, contributed to packages. There's something called AODV, which is an ad hoc distance vector mesh network. There's Batman, which is an acronym for something like better than I don't know. There's the Fry Funk guys, who are a bunch of anarchist wireless hackers in Germany, who have taken the OLSR, which is, I think it's open loose source, sort of least cost or loose source route protocol, and they've kind of hacked it to their own purposes, and they're very active in putting out updates to that.
So maybe you could like post that to the list, or
Yeah, I'll just type it up at the end
here.
here. There's a bunch of them, and they're all being kept up and maintained as Linux packages do.
Is there a is a part of the staff that can run a Zigbee as a modem
Yeah.
for basically for Wi-Fi approach?
Oh, you mean like, can you use Zigbee as a modem?
Meaning that Zigbee, you take the like an XP board and be able to run that into. We're trying to figure out how to do reset. A pair of Zigbee boards that you can work through as though it were an Ethernet connection between the two, but at low speed.
Yeah, because one of the modes that the really simple answer to that would be to run PPP over it. Because one of the modes that Zigbee does really well with is as a serial pipe. The cool thing, one of the things that I like about Zigbee a lot is that it's a minimal setup and basically almost an instant auto mesh. You set the PAN ID on each of your Zigbee modules, and they go out and self-discover and figure out who has the same PAN ID, and they auto-associate. So the coolest thing about Zigbee is that you can take this. Somebody else have a laptop with a see what I've got here in my case. I may have I have this. So that, and I've got its brother around here somewhere.
Is that a Zigbee transceiver?
Yeah. This is an XP. This is actually really cool. This is made by Adafruit. It's made by Adafruit. Let me hold it up here. This is if you want to experiment with Zigbee and you don't have one of these, you should get on SparkFun or Adafruit right now and buy one. First of all, the cable is a USB to TTL. They sell USB to TTL cable, which is probably one of the single most useful debugging things and just general hacking tools I've ever bought. And for 15 bucks, it is USB, and you have the just pinouts, the 0.1 pinouts here. And the cool thing is that the guys who made this, they designed this board to mate with this cable. So all you have to do is plug it in. So if somebody else brought their cable, I've got another module set to the same CAN ID, and we could do a quick demo or something. Or if somebody wants to try and breadboard something up really quick, it uses 3.3 volts. No, this actually uses 5, and it steps it down internally. So just I don't have 2 cables, otherwise I would have brought them and handed it out as another demo, so we could test it out. But it's blinking because it's blinking green because it's looking for something. If it found another node, it would turn red. And they're just really, really cool. I like them a lot. And the boards are cheap. They're like 10 bucks. And basically it consists of some little custom headers which you need because XP uses 2mm instead of uses a smaller pitch. Instead of the 0.1, so that's kind of annoying. But other than that, it uses a picofarad capacitor, 74HC something or other hex inverter, and a 100 microfarad capacitor. So basically, what I've done is I just go out, I buy the PC board, I buy the PCB for $5, and paying them 15 for the whole thing. And I take around my bits box and I make them myself.
Steve, what Linux software do you use to configure Zigbee?
Okay, so here's actually kind of the cool thing. And I can give a demo of this if we want to pause for a second here.
Keep going.
Yeah, okay, keep going. All right. Basically, here's the cool thing about like Zigbee and some Bluetooth modems. A lot of Bluetooth modems, 802.15.4, and even some of the embedded Wi-Fi chipsets that you have out there. If you don't have a UI, if it doesn't come with like a web UI or some sort of a custom tool or something like that you got from the manufacturer, start up a terminal and try typing a triple plus. 9 times out of 10, you will get an OK back. And if you don't, go and look in the configuration, go and look in the doc and see if it doesn't say something about, like whether it comes up in a command mode or a data mode by default. Because just about everything these days is using some sort of is using the AT command set. So we have like this little embedded Bluetooth module here from BTM, which responds to the Hayes command set. But they're all different. They're all so you can do like ATDR and you do triple plus and it goes okay. You say ATDR on one of the XB modules and it gives you back the data rate. You say ATND and it gives you the node ID. You do like ATSI and it initiates a scan of a radio scan for other nodes with the same PAN ID on the same channel. So that's how you configure it. There's no special software. You pop up Minicom or your favorite terminal, and you kind of hack around on it. The one thing you have to worry about with that is that usually out of the box, the default guard time for these is really short. So if you do get that okay back, you have to type really quick, otherwise it will just figure you didn't want anything and will go back into receiving data. Just really quick, data versus command mode. Most of these also have a thing called data mode, which is where they will not respond to that attention sequence. Because if you ever hope to send any binary data over that, like video or an image or something like that, you're going to want to ignore the escape sequence. Because this is all, so usually what it is it's if it gets the triple plus or it gets the guard, the attention sequence within like 100 milliseconds or something like that. So if you're transmitting, and it doesn't matter, the chip doesn't know whether you're sitting there typing at it or if it's encoded in the data somewhere. So if you're sending like JPEGs or screen dumps or video or something like that, and it's all coming across as bits, all coming across as either like characters or bytes or something, how much do you want to bet that somewhere within your image there's going to be those attention characters, at least 3 of those attention characters encoded with your image? I can tell you from experience, they're there. I had, when I was first using Zigbee to take screen dumps off my CMU cam, and it would like randomly just hang up in the middle of sending an image. Some of the time, not all the time.
Yeah.
Some of the time. And I figured out, I started looking at like hex dumps and think, well, there's the plus character. There's the plus character there. And there's a plus character down here. And I'm asking for this at 115, 115.2 K baud. Yeah, that's definitely, it's just like, there's one escape character at 23 milliseconds, one at 56, and one at 98. That's 100. And so and when it goes into command mode, it drops the connection. That's the real key thing here, is that if you actually send that escape, it stops everything and goes, okay, I'm waiting. And so, mid-data transmission, your connection goes. It's a really, the thing about the 2 modes is that once you go into the data mode, because of what it's supposed to do, you can't get out until you either power down the chip, or sometimes you have to short 2 pins together to initiate some sort of a hardware reset, It sounds annoying, but it's actually, it's pretty useful. So we talked about we've talked about power over Ethernet. Brief word about batteries. This mostly comes from my experience in dealing with like the long distance outdoor stuff, where it's going to stay active and up and running for a long time. But still, if you're going to run your robot over the course of a day or something like at Maker Faire, or if you're running it, you're testing something in the lab and you have it up for most of the day, it's still a good idea to pay attention to. I would, and the basic advice is avoid motorcycle and car batteries whenever possible. Because what do? You turn the key and it sends a charge, right into the starter, kicks the engine, which starts the alternator, and then immediately starts to charge the battery back up. So you have this really short, powerful drawdown on the battery, which then gets, pushed back up, hopefully in a few seconds. That requires a different technology and different chemistry from something that is just designed to slowly discharge over hours or even days or weeks. And if you're using something, like the 2000 cold cranking amps, kind of, we'll start in 100 degrees below zero. They use this at, McMurdo Station to start the C-130s kind of batteries. That's much different technology, much different battery technology than from what you want to keep a robot that's going to be circling around a volcano crater for 3 weeks on end and constantly staying, online, or for little wireless sensors or something like that. So instead, I would recommend for keeping radios and stuff active. Probably the amps know about this already. You can use something called a deep discharge battery, which is designed to be degraded and continuously drawn on over and over and over again for hours or days. And then even then, kind of the guideline we use is you should only discharge it to about 70 to 80% below full capacity to prevent long-term damage to the battery. Because the unfortunate thing about batteries is that they're still chemical and analog, even though you have all this charge, current leveling, protection, voltage evening, blah, blah, blah. We have all these circuits and everything like that to make sure that you get clean power. There's still a chemical reaction happening back here. Yes?
Are you saying you should only use about 25% of the energy in it?
I'm saying you should, if it's like rated to like 12 volts at 4,500 milliamp hours, you should discharge it to maybe like 3,800 or something like that, or I guess the kind of the very rough kind of back the envelope that I use is that if I've got it below like a volt, like below 1 or 2 volts. Like if I have a 12 volt battery and I put the multimeter on it and it's like 10.58 or something like that, okay, time to recharge it.
So really what you're saying is discharge down to 20 or 30%.
The question is whether you're consuming 70% of the battery or you're leaving 70%.
You want to leave, you want to leave 70%. You want to leave 70%. If you want to hold on to the battery for, a couple years.
So sealed lead acid, for example?
Yeah. If you want to have to replace your battery, like, once a year, or, once every 6 months or so, if you want to hold on to it for like 2, 3, 5 years, then you should only discharge about 20% of it. Which still, can get you a lot of runtime, depending on what you're doing. It just means you swap it in with another battery, put that one back on charge.
Do you mean to do that even if you are using a deep discharge battery, or?
Yeah, because they'll only discharge so much. I guess the thing is that you can let it go, but for any battery, you don't want to ever let it go completely down. There is a point where you will deplete the electrolyte or you'll imbalance the chemistry of the battery to the point where it can't really be repaired through, it can't really be restored by putting power back into it. You'll have changed the chemistry significantly, depleted or changed the chemistry significantly enough that just applying an electrical current to it won't restore it to full capacity again.
Does that apply to lithium too?
I don't know so much about lithium, because like I said, this starts getting into chemistry.
Actually, lithium is worse. There's a bottom level, and you hit that once, essentially, and you get to go buy new batteries, which is why lithium batteries almost always have electronics with them. So, it's like your cell phone is smart.
Okay, I just want to get through some of this really quick because I think this will all help with, this is all stuff that I think would be useful to know for putting antennas and wireless connections on your robots. Antennas and antenna hacks. There's two basic types. You have an omni and a directional. I think everybody knows this. The omni is your typical kind of your rubber duck is a good example. It radiates in a donut shape in all directions, omnidirectional in kind of one plane. So you have like this donut here that it'll radiate in, and then above or below, so the signal is kind of within this globe here, within this donut, which is why you'll see you have access points will be like hanging from the ceiling down into a space. Is so that the donut kind of circumscribes the meeting space. And some of the stuff that would probably be more interesting to us is embedded antennas. So here's kind of the thing. So you have this omni kind of donut shaped thing that is in the access point, and you're trying to connect to it with these, which are panel antennas, and have a decidedly different receptive pattern. They're receptive kind of on one side, and the back side not really so much. So this is like a Bluetooth, source amount Bluetooth chip. This is like a little USB thumb for Wi-Fi. And this is the antenna on that mote that I've been passing around. It's just a little kind of guide inscribed on the back. Kind of like in your laptop. Yes?
Earlier you were talking about cellular. Are there any cellular transceivers that work in this ISM band?
No. Most of the cellular ones operate in like 1800 or 1900 or 900.
License bands.
They're licensed bands. They're a little bit interesting. Cellular, because you can buy embedded cellular radios. You can go on SparkFun or Adafruit or Mouser or something, and you can order up cellular chipsets, and you stick a SIM in it, and it works. But that's actually kind of the key there, is when you stick the SIM in there, if you go onto the carrier network has been certified, and you're buying the SIM, which has, so you're basically, you put the SIM in, and it's licensed. Because it's only going to register itself. You bought a T-Mobile SIM, or you bought, I think what the one I was using in Bangkok's Happy Time. But you bought their SIM, and that cellular company has registered with the local communications authorities, and so that's how that works. You plug the SIM in, and it goes off, and only registers with one set of antennas that have been verified and certified, and blah, blah, blah. So very quickly for laptops, these are kind of the antennas that you'll typically find on a laptop. Things like, like this, they tend to have the antenna like as a metallic strip, so like along the back of the case there. So for the sort of the typical, if the Omni is a donut, these are kind of a flat, kind of I don't know, I guess like a mushroom, where you have most of the receptivity and transmission, most of the RF beam is right along in here, and you have like some side lobes, which is not really, you're not going to get a whole lot of, you will pick something up. It's like when you think you see an access point and it just kind of wavers. You're just picking up one of these things called a side lobe. So what does this mean? It means that you should, I've seen some people do this on their robots where you have the Wi-Fi pump sticking up vertically like this. And you have the thumb sticking up vertically like this, and if this is your antenna, then your receptiveness is in this plane when you're kind of sort of being showered from above by the Omni. So instead of having it like this, you should have it maybe, if you need to have it raised up on a platform, but have it like that. So that the face of the active side of the antenna is receiving more of the RF energy. Because if you're doing it like this, it's just kind of like raining down. You're not picking up a whole lot. If you have it like this, I think you get the point. But an Omni can be turned into a reflector with a little hacking. So just this is a piece of styrofoam. This is one of my things my buddy Carlo in Italy did. Stuck a piece of styrofoam with some aluminum foil on the back over top of an Omni, and suddenly it becomes a directional reflector. Or one of the things that the guy that my buddy Ano from Indonesia figured out is a way to turn amplify the range of the little USB thumb. Is you take a wok, which is a parabolic reflector, because it's designed to accept that it reflects heat, into the food rather than RF, but it's still a parabola, and you stick the USB thumb in at the focus. So RF comes in and it bounces and it comes back and it focuses at a point because it's a parabola. And if you put the USB thumb on the focus, you get the maximum RF, you have the maximum receptivity right there. And so this goes from like being like minus 89 or minus 103 dBm receptivity to like 43 or 27. Okay, so wrapping up here, this is something that I'm working on right now. This is a project that I'm working on right now. I'm going to try and give a demo of. This is something I've been working on for. I actually have a demo of have an Android app that actually works. If people want to try it out, I'll install it, or you can download it, or whatever. I've got it with me. This is using the question. Well, the problem is that Wi-Fi passwords are really complex. You make people type in these really long, this is a very secret password into their laptop. That's great for a laptop or for a desktop. Try typing it into an iPad or a phone. Try typing it in when somebody says, oh yeah, it has to be 20 characters long, include one special character, at least upper and lower case, no punctuation, no, and you try typing it in on a phone to get on a wireless network, it's not going to happen. So, the thing I'm working on is called Nyala. It uses a fiducial marker, aka a barcode, to contain the password and the SSID and all the stuff that you would normally have taped up on the wall in a barcode. And you scan it in, and it uses that information to put itself on the network. So if you don't have a keyboard, like you're using a phone, or if you have a robot, you would use this to scan in, and basically this lets you put the robot automatically on the network. It scans the barcode, downloads all the which has all the information it needs to know, and it sets its radio, it sets its to I'm going to use this encryption with this key on this channel with this SSID name, and it works. And the other cool thing, the other reason I think this is useful and interesting is because robots are soon going to face the same kind of issues that we face. If you've all seen the demo of the AnyBot that goes around and orders coffee and picks up coffee and scones for the people back in the lab, and then rolls back to AnyBots. That's great when you're in Mountain View and you have the Google network and you're essentially in the same Wi-Fi domain because it's doing this roaming with the same SSID and everything, and so you can't roam easily. But eventually, somebody's robot is going to go from one office to another and face the same problem that we have when you come here, or you go to your office, or you go to a friend's house, where you have to ask them, so how do we get on your network? And this would be a way to have the robot put itself on there. And then finally, very finally, another application to get your robot talking IPv6. It's not scary, it's a lot easier than you think. It really is the network for robots, because with IPv6 we now have enough address space to give every robot and every device on the planet n times over an IP address. And the hardware is already there. That thing speaks IPv6. My Mac speaks IPv6. Your BeagleBoard, your Linux laptop, your Windows machines, they all have the capability to do it. We just have to do it. And there are even some ISPs out there that will either tunnel for you or they will speak it natively. We just have to do it. And that's it.
Are you going to do the demos?
I can try to do the demo. Can I see the who has the bullet?
Bullet.
Don't strip your robot before the demo.
Yeah.
Uh-oh.
Got the moat and bullet.
And if you have any problems, we'll just do the demo and.
Do the demo. We can do the demo and show. Are there questions?
Questions for Steve?
Because we can do this during show and tell. I have like.
Yeah, there's a question back there.
Oh, with the power reconnect, you said that there's like a little box where you can inject power into like an Ethernet cable that doesn't have it. Is there like a converse thing if you have like a device that's like somewhere else in your robot, you want to use Ethernet and send power, but the device actually can handle the power on those things?
Yeah, here, let me just show you. I'll strip my robot again. This is going to happen during show and tell.
We're going to show and tell for the demo.
Yeah, this is so this is the block right here.
Yeah.
So you just have the Ethernet and the PoE, you have power. So if you wanted to run, if you have a powered cable, I guess you could do that. Mostly these things work with the power coming in, through the block. You have your power come in here,
yeah.
and there's like wires are twisted around in here, so that the PoE side, you have the ground and power are twisted into the data cable, and it comes out here as. So that's kind of how that's set up. Right. I haven't tried it. Where I took a PoE cable, ready cable, something that was already carrying power, and plugged it in. I haven't tried that, mostly because, as you saw, if you get it wrong, the results are basically no more radio, possibly no more robot, possibly.
Let's do one more question and then we'll.
Let me know how it works for you.
I've been doing PoE for security cameras lately, and I discovered that you can buy cheap injectors and just use the extra pairs, put the power in on one end and take it out on the other end.
Okay.
And then there are expensive ones where you plug the one box into 110 or whatever, and it sends 48 volts typically on the cable. And on the other end, there's a box where you can set a switch that says whether you want 5 or 12 or what. The hardest part is getting the connectors that match up with your cameras, but they exist and you can buy them in pairs.
I'm actually really happy to hear that there's even 5-volt PoE, because for the longest time the thing that made this not really accessible and reasonable for robots was that it was like 48 volts, or Cisco uses 52 volts. I think mostly because that's my company. They like to keep it so that you have to get stuff from them.
You need high voltage in order to go long distances on those little wires.
Yeah. I mean, it makes sense, but it's like, dude, 52 versus 48. That really makes a difference. Really. But I'm really glad to hear that there's like even 5, because that's cool.
So the 5 is not going on the cable, it's what you convert the 48 to at the other end.
Oh, okay, so this is a selector switch, so you can step it down internally.
Right.
That's still kind of cool. Anything else?
Okay, let's give Steve a big round of applause. This talk for at least 2 years. I think it's closer to 3.
Yeah, it's been a while.
It's been a while. So we're going to do some final wrap up here.